Now that we've had a chance to talk about the Java executor interface, and you get the basic gist of how this concept works with different types of thread pools and so on, we're going to go and talk about the Java ExecutorService interface, which overcomes a lot of the liabilities or the downsides or the cons with the executor interface. And we'll see that it has a lot of powerful features, and we'll also talk about some of the implementations that you can associate with the ExecutorService interface. The first thing to notice right off the bat is the ExecutorService interface extends the executor interface. So that means we get the execute runnable method by extension in the ExecutorService API. There's a whole bunch of methods here that go above and beyond what you can do with the simple execute method from the executor interface, however. And these different methods allow you to submit one or more tasks and then get back something called futures that you can use to manage the life cycle of those tasks once they are submitted. There's also some methods in the executor service that are used to manage the life cycle of the executor service itself. For example, you can interrupt the worker threads in a pool, and you can also have ways of being able to manage other things as well. But these are really useful for being able to manage the executor service implementation. You can tell it to shut down, you can check to see if it's shut down, you can see if it's terminated, you can wait for it to be terminated, and so on and so forth. And we'll talk about those methods here when we get into the details. As we talked about earlier, but now we're going to go into a bit more detail, a task is a unit of computation that ideally doesn't depend on the state, result, or side effects of other tasks. In other words, it's embarrassingly parallel. The task lifecycle has 4 phases. Once again, we see the sort of the wheel of creation and destruction here. Created, submitted, started, completed. So as you might expect, when the creation phase, a new task is instantiated. You make an instance of something that's a runnable or a callable. You then submit it using execute or submit, which are these methods for adding callables or runnables to the queue of things to process. Once a thread in the pool has gotten its grubby little fingers on a task to execute, it will go ahead and execute it by either invoking its call method, its call hook method, or its run hook method. That's how things start running. And then once a task is done, it is considered completed. And there's a couple of different ways you can complete. You can complete successfully, so you do your thing, you get the result back if there's a result. You can also finish unsuccessfully, which typically means an exception has been thrown, or some other thread can cancel the computation. And right away you can see this is very different from what you can do with the executor framework, the executor interface, which didn't give you any of these ways of controlling anything. So being able to cancel operations that are running asynchronously without waiting for them to complete is another value-added capability that's provided by the executor service interface. So that's the end of the overview of the executor service. Once again, there's a lot more to all this stuff that we'll look at, but this will get you started.